Can you find the PowerPoint, the PDF I upload in this Zoom, Teams? Because the Dr. Ennis haven't uploaded the course, the PDF. So today I add the PDF in here. So can you see them?
Yes.
Okay, thank you. I will share my screen. So today we are going to talk about the information theory, and before we talk about the information, and let's uh, go back to the first course, and we studied what is the some main concepts of the information. So for information, and the definition is the set of the facts and the events in surrounding the world, and information has some characteristics. It can be the store, convert, transmitted. So we already know about the uh, information, a little bit about information. However, we talk more about the symbols, and it has the different characters, and for the information storage. So in the symbols, and there were lots of information stored here, and also for the message, and order the set of symbol, which means the information also contained in uh, uh, I mean the message also contained in the information. So, and the signal also care about the information storage transform. So it means the information is the most important in the telecommunications systems. And today we will study what is the information theory, and how it will uh, what some uh, specific characteristic it has, and let's go. And let me resume it. Okay, so and for the information, and here has some um, characteristics, and first it has some abstract phenomena, and it needs some mathematical calculation, and we can do the storage, communication, and quantity evaluation. If we want to talk about the information, so and Claude Shannon he's the father of the information. So in this article, 1948, a mathematics theory of the communication, and this article to show the how it information um, uh, store storage, and also the calculation method. And I also download this article, a mathematics theory of the communication. Let me show you here. And it's around 50 pages. Maybe if you are interested about that, so you can just Google it. It's free to download. and you will see what is the detailed information theory, and he has some explanation and of the detailed mathematical process. And or maybe if it how to say, if you don't have some strong mathematical background, so maybe you will feel a little bit difficult to understand. So I also recommend you to download this tutorial. And Shannon's coding theorem comes from the St. Mary uh, College of the, California, and this tutorial, which might uh, will quite easier than if you read the direct paper, the mm, Shannon's paper. So it has some more and detailed explanation on the uh, Shannon's coding theorem. And it's not very long, and let me check it, around 21 page. So it also can download from the internet. Just Google it, Shannon's coding theorem, and St. Mary's College of California is also free to download, and much good for you to study it. And let's come back to the lecture. Um, so next we will talk about the Shannon's theorem, and in his article, it mainly find it can be proved that computation uh, without errors it is possible. So if the correct code is used well before this proof and is unimaginable. So let's see this process, and well, it may be um, difficult to understand. However, I will try my best to explain. So if we have some message here, W, and message, well, I don't know, it can be the uh, capital or letter in here, and you will have some uh, order, so consists of the message, and we use the encoder here, like fn will be the function to get the encoded sequence xn. So the sequence will be a vector, and we will send it to the channel. And channel here also x will our input, y is here received sequence, so it will be the input output. However, the xy also can be the vector if it has the x1, x2 sequence, and so on xn. So y also will be the y1, y2, and go on yn. So if there is no mistake, so we input the x1 and then we receive the y1, and there is no mistake, and so we can see we can do the decode here, G, and the decode we can get the input message. We call it W head, which means the message is no errors, and it can the it will be a complete message and no information loss, and the error will be the probability of the error will be the 0, which is uh, a whole uh, information message transmission process. Let's go. And in the Shannon's article, and it said all possible symbol A, which means a vector, and can be the transmitted and received with noise. It can be with noise, and noise also can be considered as some how do you say, information here. Information. So the set of the symbols called an alphabet, which is quite similar with the English alphabet, and for it for the discrete systems, the alphabet has a finite number of symbols. So it's also same with the English alphabet. We have the how do you say, countable letter. So not for the discrete system, but also for the, how do you say, for the digital system, because we mainly talk about the digital communication. Let's go. And here, if we have the source, and it can propose a random choice, and well, it has some probability, and statistical here. I don't know, have you checked out your course project? I think you already see your individual symbol and the probability here, right? So um, we in my case we have the, how to say, from the A1 to the A9 symbols, and how can I calculate the each of symbol has the different probabilities. So suppose we have the some message here, and if we have the, if our A1 if our A1 A1 is A if A1 is the letter A, so which we count how many A in our message, then we can A. So we calculate the how many A and A in all letters here, and we can get the probability of the A. So that is the method, and the probability of the each choice, which close to related to the information volume. Let's go, and we can compare two messages here. First is all living beings need the oxygen to breathe, which is true and definitely, and all alien life. Second is the alien life has contacted the human race, and how do you say, a small possibility, and we can see it's not true or impossible. And so for the first message, it obviously and uninformative, and so the probability, this things happens probability, which is 100%, and we yes, that is true, that is fact. And the second, can the second message can give us a lot of information. Where is true and so the probability will yeah, here it's managed and the probability will, I say, this things happen, probability will turns to zero, and well, we don't say it's 0%. We just say it can get some relation to the p. It will tends to the zero. So, and let's go. And for the information amount, and it has a function of the message, which called is or message or symbol probability, because the message also consists of the symbols here. So we will find this function what is the to represent the information amount. Information amount here in GA, and we know that has some contradictions for us, and if the information amount equal to 0 and the probability will be the highest choice, which means if the probability equal to the 1 and the information amount will be 0. If the probability tends to 0 and we can get the max information amount, and we need to discover what is this function. Let's do it. So we have some intuitive approach, and when the multiple message follow each other, we have symbols here. Message, it has some message. So which of them will const a lot of symbols here, and however, if we see the message and they are quite related, right? So we can like message this spell, and we can not use that. We just skip the E as skip as a. So if not, they are relied, and we don't know what they have the less information. So in this case, we can see the AI and AI and AG, they are not independent and identical. They are reliable of each other. So the total information will be here. Use this both information J, AI, AJ. It cannot. So here there is mistake. We this formula only for the AI, AJ, they are AI, AJ, they are only the information IID. So in our case, no, we cannot write this here, and we must write the GA, and also the information amount of the AJ also relied on the AI, so it can be right here, AI. And if we can use some probability theory to represent this event, we can reshape the addition function to the multiplication function, and we use the the probability of the both message AI aging and the information amount of the JAI can rewrite as the probability of the PAI, and the JAG we can also write as the conditional probability. And here, I don't know if you find some mistake here, and condition will be the here, I think. Because the AJ, the order, the AI is the in front of the AJ, so the AJ will be rely on the AI, so it will be the AI of the AJ. And the only change is here, we use with multiplication function to replace the addition function. And we can denote the P equal to the first message AI probability of the AI, and the Q, which is the probability of the AJ. So then the total information amount can be described as this function, and JAI AJ will be the F P. Yes, here. And this is P and this is Q. So P multiplied with Q, and which will equal to the GFP plus FQ. So, and the FP plus FQ will be this function. And we need to find what is the F function. We need to find out what is the F function. And so we denote as this function, and we can call the derivative for the variable P. And in here we calculate the I think it will be the partial derivative, because we have two variable P and Q. So let's do it. Partial derivative F will be the P multiply Q with the P, and it will equal to the FP prime here, which is here, and will be the P multiply Q, and we do the both to we use the both to do the derivative, and PQ P multiply Q is the derivative. That is our left equation function here, and we only do here, and we did the right part. We also do the deviation. So let's do it. FP, and it is the FP function. So we just call it FP, and P. And in the FQ function, there is no P variable for the deviation, so it's just equal to the 0. And after sort, we can get here peak to P. This part can only equal to the q. So after sort, we can get this function. And you will see here the detailed calculation process. And we will get, and step we will multiply the both part by the p. So use the p multiplied with this part, and we can get this function. Let's go, and the function type will be the both part with this function. So we consist as the here, and we consist as the p multiplied q as a one part, and pq as one part, like f in pq, and can be consistent as one part. So will be the f multiply fp f p and fp prime p. So this part means the same after multiplication of the both part, we can get this, and the same idea is here. We denote the p and denote p multiply q will be the x of f, and we can get this part f multiply the f p prime, and f will be the p multiply p, and it can be the equal to the k, which means it's a constant. So we only use this part, and this part we don't need. When we get this part p multiplied with the fp prime p equal to the k, let's do some both part to multiply with the one of the p, and we will get this. Both part you will multiply p, will get this, will be the fp prime p, will be the k on the p. And we next step we will do the integral with the both part of the p, and we can get the fp plus a constant and do the integrals with this part, and which will equal get the k is constant, so we take it out, and both are here up. Yes, here we'll get this part will get equal to this part. We get the first integration to get the constant c1, and the right part we do the integration, we can get the c2 constant. So that's a little bit short. We can get this part. We will get the fp from this function, and we plus c, which means c will be the equal to c2 minus c1. Now constant minus constant also be the constant. So in this case, I think we almost find the what is this j? We already find out what is this the f function here will be the fp equal to the k. So k will be the coefficient and the log EP will be this function. So if you still remember the FP, the line is a graphic which looks like this, right? And from the E already equal greater than 1, and we got this function. We can see the line P. So when the P equal to the 1, so the of the on part will be the only the constant, which means also can be 0. So which means the P can be the information amount of the J AI will be the if the probability to the P, the probability will equal to the 1, and our information amount will be the 0. So, and here we'll I'll here mention the how can we determine the constancy and use some intuitive knowledge, and yes, the J and yes, here we can know if the J L equal to the 0, so the master the P will equal to the 1. And we got the constant will also equal to the 0. So in the function type, the information amount is estimated as this function k multiply the log p, and k is the dimension coefficient. So there are two problems, and it's a negative amount, which means the line will, if the line p will line p less than 0 in the condition the p less more than 1. So we hope to get let's come back to the graph, and we hope to get the smaller probability in order to achieve higher information amount. However, if the p less than 1, and this part will be the negative. So for the k, we hope to k should be always should be the negative, because the negative multiply negative will be the J AI will be the positive, and the desired measured unit will be the bit. So which means it means the bit, and the information amount unit will be the bit. So, and how can we get a bit? I see the how can we get the unit bit, which means the 1 bit? So in the telecommunication system, and it is the smallest measured information amount, and where with uh, the information, and which means information. This consists of the unit will be the bit, and it can be stored in the uh, symbols, and also can be stored in the message, and also can be stored in the signal. So maybe their relationship like this. And here is some definition about the bit, and it comes on Wikipedia, and we can see here the bit is most basic unit of the information in the computing and the digital communication, and the name is a construction of the binary degree. The digit and the bit represent a logical state with the one of the two possible values. And these values are most commonly represented as either 1 or 0. And we also can use the true false, yes, no, plus or minus, or on off. If you remember on off, we will use a lot for the NRZ. Now written to 0, we use the uh, voltage level to represent the to signal, and use the like here, which is 1 voltage, and to represent with the uh, 1 bit, and we use 0 voltage to represent the 0 bit, and for for the now written to 0, and it's also same here. Voltage will be the 1 bit. No, it's 1, and 0 will be the 0. However, it will be the unit uh, digit. So let's go. And for the and in such case, the function type. So we got the k equal to the -1 divided with log 2, and we can, if we can get a new representation format of the information amount of the AI, and use this function, we can get this uh, minus log 2 pi, which means the bit per symbol. So the maximum information of the 1 or 0 symbol is only if the probability P0 and P1 equal to the 1/2. And how can we get this information? So why here is the P0 and equal to the P1 equal to 1/2? How can we get the maximum information? Because we'll here, okay, no here. So we will see here. use some graphic to understand about the. And here the information of the JAR, and where it will looks like this. And this is a probability, and we can. So from the both sides, the information for the both elimination for the probability equal to 0 or probability equal to cancel to the 1, and then the information amount will be the 0. However, if we can reach to the highest proper hope to achieve the highest information amount J, and the probability can be reached to can be equal to the 0.5, 1 or 2, and the probability can be achieved. The amount can be the maximum according to the its graphic and characteristic. So let's go on. And we will introduce some new this theory, entropy. And here is some definition about entropy also from Wikipedia. However, we will study about that after the slides. So the entropy, which means can be the think about the it will can consider as the average information amount. If we have the non-binary source and the different information amount, so each symbol has the different different information amount for the each symbol. So which means the each symbols J, how do you say, JA1, JA2, they are not same. And here we use the four digital pulse code modulation wave, and it can up to the 16 different symbols. And for the PCM, we use the here the 9 code. We choose 9 code. We choose the NRZ for the one code 1. We use the pulse. For 0, no pulse. Quite simple, quite easy. And here, however, the 4 digital the code with up to the 16 symbols. So which means each symbol will coded by the 4 digits here, and however we only use the 9 here. So if we use the 3 digits here, and it only can reach to the 8th symbol, which means will be the 0 0 and 0 0 1 0 1 0. Okay, 0 0 0 1. Yes, if we have the 9 symbols, so the 3 digits cannot store the one more symbol. How we will reach to the 1 1 1. So the last symbol will use the 4 digit here, and the we cannot use, in this case, we cannot use the 3-digit. If you have the only 8 symbols, we can use the 3-digit here. And the 8 symbols. Sorry. Okay, so for the most significant bit does not carry 1 bit because we have 4 digital and the efficient will around like this, and the efficient of the entropy will calculate as the how to say, use the previous function here, and the entropy will be like 2.3. And it cannot carry 1 bit, will be the 4. We have 4 digits here, and the efficient only 0 to the 0.6, which means it's more than 1 bit. So the efficiency is not good here. And the average information amount here. So we will use the statistical information, which is provided by the average value for the each source, and we call it entropy. So we need has each of symbol has its probability, and how many symbols do we have, and we can calculate of the entropy. And let's come back to the here. We detailed introduced about the entropy from the Wikipedia, and the entry in the information theory. The entropy is a random variable, which is the average level of the information, and that comes from the Shannon's paper, and it has some with the probability and with and on the head and the probability 1 minus probability of the 90 ohm tails, and the maximum price for the 0.5. And here is some detailed definition here. If we give a random variable x and the possible outcomes of the x1 to the xn, which occur with the probability of each of them has the different variable has different probability p x1 to the xn. So the entropy can defined as this function as we introduced before. So sigma denotes sum of the variables possible value and the choice of base for the logarithm, and the base of the 2. So here, if the base we choose the 2, then we can get the unit of the bit for Shannon's, which we needed. And if we get with the E, we give a natural unit net. And if we give the base of the 10, we can get the unit of the digits, and or bands and other. That is the definition of the here. So the entropy, which measured of the efficiency, and which is also the quantifies level of the uncertain of the symbols selection or by the source. So the high the characteristic is the higher uncertainty and the higher entropy, and the maximal source entropy is limited with by this. N is um, the symbols numbers. However, entropy must greater than 0. Next, we will introduce what is the maximal entropy. And there has two conditions here. And firstly is all symbols must be equal to the same probability. Pi equal to the 1 of the n, which means all of the symbol has the same probability, and no correlation or specific the order of the symbols. So we use this function and calculate like this, and finally we get this function, and which we introduced before, and we give the probability here, and we use the information amount, we use the entropy to replace the information amount with the y-axis, and for the x-axis, which means still the probability of here, and if the probability equal to the 0.5, and the entropy also can achieve the highest entropy, which will be the 1 bit. And however, we still have some formula to define the binary entropies function here, and their relationship. And in the course project, we will learn how to calculate it. Okay, so entropy. Maybe we can take 10, 15 minutes break, or we can like 35, 9:35. Okay, stop sharing.